Hi guys, we're going to do another round of solving equations. These ones we are going to solve from 0 to 2 pi, and actually the nice thing about today is that, maybe this should have been day one, but that's all right. Most of these, if not all of them, I can't remember everything that's on the suggested problem page, but you notice how this is just plain old theta, right? Just plain old theta. So when we actually solve it, we're not going to have to do, the whole all solutions things where we do plus 2 pi n, and then we have to figure out, there's not going to be, there's not use substitution or anything like that for this, and we don't have to then use the quote-unquote all solutions to figure out our solutions from 0 to 2 pi. The very first thing that we are going to do is look at this lovely fraction. Hey, that is -3 plus radical 3 over 5, right? Because I can write that as two fractions. And so this is a -3 plus 6 over 5 tangent of theta equals -3 plus radical 3 over 5 plus tangent of theta. All right, so you're going to add 3 to both sides, and that's going to go away. And I'm going to subtract tangent theta from both sides as well. And so I will get 1/5 tangent theta equals a radical 3 over a 5. I'm going to multiply everything on each side by 5. And so I'm looking for where tangent of theta equals radical 3. And again, use your calculator to help you out. Do inverse tangent of radical 3 to get your theta. And you will get, for this, our theta is pi over 3. And then, of course, because it is tangent, right, tangent involves both y and x. So then we go, pi over 3 is in the first quadrant, so then we go straight across the line to the third quadrant to get 4 pi over 3. Because it's the same y and x, they're just going to both be negative there, and so that will end up being positive tangent. Next one, I'm going to factor out a GCF. There's a couple ways to solve this. I tend to just like to, and again, guys, if it helps, you can rewrite this as 0. Oopsies, you can't do it that way because I used the highlighter. That doesn't show up very well. You can rewrite this as 0 equals 2x minus radical 2xy, right? I mean, because you just let your cosine be x and your secant be y. You're just plugging in variables. If you need to do it in, that algebraic way, that's totally fine. The other way, of course, is to actually just leave the trig alone and factor out, you're going to factor out a cosine. So, but again, if I was working with just the algebra, I'd be factoring out an x. So when I do this, I've got 0 equals cosine theta out front times 2 minus radical 2 secant theta. So I have cosine theta equals 0. And then when I do this, I will have 2 minus radical 2 secant theta, equals 0, sorry. So then secant of theta is going to be 2 divided by radical 2, right? And so then when you look at this, it's really 1 over cosine theta equals 2 over radical 2. And so then you're going to cross multiply and divide, and you would actually get cosine of theta equals radical 2 over 2 when you get that. So from, cosine of theta equals 0 over here. Sorry, I forgot to write that. So from here, we get cosine of theta can be, is 0, so we get pi over 2 and 3 pi over 2 right here, because that is where cosine of theta equals 0. But then over here, from this one, we'll put it in yellow, we're going to get our theta equals pi over 4 and 7 pi over 4. Now, here's the deal. Remember in the second video, I told you, or actually I think in the first video, I told you should be checking all of these. So here's the thing. When you check these two answers right here, and you plug them in, you plug them back into the original equation. So you'd actually have to plug them back in here. And so you'd have a section where you'd have, 2 times, basically 2 times cosine of theta would be 0 there, minus radical 2 times 0 there. But here, this is 1 over 0, right? Because if we let theta equal pi over 2 or theta equal 3 pi over 2, then you like that it's done. This is undefined. So these actually are not, you can't use them. So these are your only answers that you can use. Okay? All right. Okay, we are going to use a, sorry, I forgot to press pause. I was kind of waiting for the clock to stop, the chime to stop, but I've made a lot of videos in the past 2 days, guys. I'm getting a little loopy with them. All right, so we've got, we're going to use Pythagorean identity. There we go. That's the word I'm looking for. So when we do that, we have got 0 equals 3 secant theta plus, that's going to be our secant squared theta minus 1, and then we'll write plus 3. Sorry, plus 3. I did wonder if this this pen was going to make a lot of noise when I was recording, and yes it does. So 0 equals, I'm going to put my secant squared first, plus 3 secant theta, and then minus 1 plus 3 is plus 2. And of course, again, if you need to, it's totally fine to just kind of flip it over to algebra. So it would really be x squared plus 3x plus 2. And so when we factor that, it's got to be x and x. And the only way to get 2 is 1 times 2. And of course, they'll both be positive. So when we actually go write that, it would be 0 equals secant theta plus 1, secant theta plus 2. So I need where secant of theta equals a negative 1 and where secant of theta equals a negative 2. And so remember, 1 over cosine theta equals a negative 1. So cosine theta has to equal negative 1 when I cross multiply and divide. And then, of course, this over here would mean that cosine theta equals negative 1/2, right? And so cosine of theta equals negative 1 at pi. So that's one of your answers. And then 2 pi over 3 and I'm trying to find, okay, we'll put it in blue. 2 pi over 3 and 4 pi over 3 for your negative 1/2. Okay. And again, when you go to, like, if you go back and you plug it into the original equation up here, you're okay because at pi, secant is also negative 1. Tangent is, no, that's not going to work. Yep, sorry, that does work. I was thinking about tangent, and in my head, I really did think y over x, but I was thinking negative 1 over 0, and no, that it would be 0 over 1. So you're totally fine there and there and there. So those are your 3 answers. I apologize. I was thinking it right. And it's kind of like, guys, when I say the square root of 4 is 2, and I say it as 2, but then I write 4 again. Having one of those brain farts. All right, I think we got one more. We do. We got one more. So when we look at this one, it's actually going to be another identity one because I see that sine 2 theta right there. And again, I see the 2 theta and I think, oh, crap, I have to use u substitution. But I don't have to use u substitution because I have that lovely, what is that called? Double angle identity. I'm sorry. I told you, brain fart. Lots of videos in the past couple of days. All right, the very first thing I'm going to do before doing anything else is technically I'm going to add 3 cosine theta to both sides. I'm not writing it just to save some time, even though I ramble and talk a lot, so I don't really actually save that much time anyway. So when I rewrite this, I'm going to have, oopsies, I'm going to have radical 3 cosine theta equals negative, and then sine 2 theta is 2 sine theta cosine theta. Okay, and I know that it's still, like, I still now have a sine and a cosine, so, it's not too helpful. But the nice thing is it's now down to a single theta. So when I go to solve this, I won't have to worry about doing u substitution or anything like that. I'm going to add 2 sine theta cosine theta to both sides so that I have a positive. So adding 2 sine theta to cosine theta equals 0. And again, I can change everything to x's and y's. Hopefully at this point, we're kind of seeing that it's not too bad leaving the trig in there. So cosine theta out front, and then I will have radical 3 plus 2 sine theta equals a 0. So either cosine theta equals 0 or sine of theta equals a negative radical 3 over 2. Right? I would have subtracted radical 3 and then divided by 2. So then cosine of theta equals 0 gives me pi over 2 and 3 pi over 2, right? And then sine of theta equals negative radical 3 over 2. That would be 4 pi over 3 and 5 pi over 3. And then I can just, again, kind of double check them real quick. And you can use your calculator to double check it. And I know that there's nothing that's going to be undefined or anything like that because I'm not dealing with any reciprocals.